Now, I've sketched the graph of the numerator, the graph of the denominator, and I've also drawn vertical dotted lines indicating where the zero of the denominator is, the zeros at x equals negative 4.3 and at x equals negative 0.7. I've sketched also a vertical line through each of the zeros of the numerator function. So negative 3, 1, and 5. Now my question is, what's the value of the rational function when the numerator graph passes through the x-axis? You should think about the answer to this question. You should think about it. The answer is fairly obvious, but give it some thought. If you get completely stumped, okay, but try to get an idea. You'll learn much more. Okay, well, the value when the graph passes through the x-axis, the value of the numerator when the graph passes through the x-axis is 0. And since the function is the numerator divided by the denominator, that's going to make the whole rational function 0. So your answer numerator is 0, so the rational function is 0. So at any point where the numerator passes through the x-axis, the graph of the rational function, which is what we're going to put down here, has to pass through the x-axis, meaning that the rational function is going to have zeros here, here, and here. Now, you already know that it does have zeros at these points from another analysis, but if you just had this graph and this graph, you would be able to conclude that those are going to be zeros. Okay? Now, what's the y-intercept of the rational function? Think about that. Given these two graphs, not given the equations of the functions, the equations of the numerator and denominator, just given that these are the graphs of the numerator and denominator, if that's all you had, how would you determine the y-intercept of the rational function where the numerator is divided by the denominator? Think about it. Okay, should have paused and thought about it. Well, the y-intercept here is 15, so that means, well, the y-intercept occurs when x is 0. So we get the y-intercept when x equals 0. The numerator is then 15 when x equals 0. The denominator is 3. So y is numerator divided by denominator, 15 divided by 3, or 5. So we can put our y-intercept here. Now, of course, 5 agrees perfectly well with the 5 that we had before. I'm graphing on a little different scale here, so 5 isn't as high as it was in our original graph. Now, what happens to the rational function what happens to the y value of the rational function when the denominator function passes through the x-axis? Again, think, stop, think, look at the graph, identify all the parts of this question, and see what you come up with. But I'm going to go ahead now with the answer. Well, the denominator function passes through the x-axis. And I should say the graph of the denominator function. I'll throw the word graph on the end here. Not the best way to phrase that, but it'll do. Well, it passes through the x-axis when the denominator is 0. So we tend to get a vertical asymptote, meaning that this line and this line will be vertical asymptotes. So to distinguish these dotted lines from the dotted lines that just go through the zeros, for this graph I'm going to make my two vertical asymptotes. What is that, pink? Okay, I'm going to color them to distinguish them. So we're going to have vertical asymptotes here and here. Okay, now from the information we have here, we can go a long ways toward constructing our graph. The one thing that we can't do based on these two graphs, or at least can't do easily unless we have very accurate graphs, and go to a little more work than is really necessary, unless the graph is really the only thing we have. The other thing that's difficult to do is the end behavior. That's going to be difficult to figure out from the graphs, unless you have a more extensive graph, and again, go to a lot more trouble than it's usually worth. Okay, so let's just take what we have from the two graphs, and we can construct our final graph. Our end behavior is going to be somewhat questionable. Okay, so we know, well, actually we know a couple more things. So let me address the signs, positive and negative, of the graph. And actually, I think I'm going to do that on a different clip. This one's getting long enough, so I'll stop here, and then we'll pick up the rest of the questions and construct this graph as best we can based on the information we have. And you, of course, should proceed to understand this information and make your own attempt at the graph. Even though you know what it's going to look like from before, what would you do if you had just this information, and would you be able to do it?